Hi guys, we are back again with part 5 of our semester test 2 memo. So in my opinion, I still say the test was a walk in the park, meaning it did not really require one to scratch their scalp. So without wasting more time, let's try to dive into the question. So question 5.1, it says use the definition to determine the Laplace transform of the function. F of t is equals to what? T, which is just a polynomial of first degree. So the question, it gave you a hint that you must use what? The question said you must use the definition. You must use the definition. Without scratching your skull, the first thing which you need to do is to write the definition. You know that Laplace transform by definition is given by the Laplace of what? Of f of t, which is equals the integral from 0 to infinity of f of t, which is being multiplied by e to the exponent minus st dt. So luckily you have f of t, which is equals to t. So the next step, you're going to substitute the function f of t is equals to t everywhere you see f of t. So you're going to see Laplace of t is equals to the integral from 0 to infinity of t, which is being multiplied by e to the exponent minus st dt. So from this point, with our knowledge of math 1, we can see that here you are having a product of two functions under the integral. This implies that you are going to apply your integration by part. You're going to apply your integration by part. You can use whichever the method works for you, but in this case, let's try to use the tabular method because it is more simple and save time. So you're going to have your table, sign, your d, and your I. So you have plus, minus, plus. The differential function is going to be t. If you differentiate t, you're going to have 1. If you differentiate 1, you're going to have 0, and then your integral function is going to be e to the exponent minus st. If you integrate this one, you're going to have minus 1 over s e to the exponent minus st. If you integrate this one again, you're going to have 1 over s squared e to the exponent minus st. So you're going to multiply in this manner. You're going to multiply in this manner. Choose a proper color. So you're going to multiply in this manner. If you multiply in that manner, you will end up with having the Laplace of t, which is equals to what? Negative t over s is negative t over s e to the exponent minus st, and minus 1 over s squared minus 1 over s squared e to the exponent minus st. We still keep our limit from 0 to infinity. From 0 to infinity. So from this point, what we have to do, you just need to substitute the values of your infinity. We're going to substitute the values of your limits, so we're going to substitute the value of 0 and the value of infinity in this function here. But we already know that our limit of e to the exponent minus st approaches infinity is equals to 0, meaning that any term that consists of e to the exponent st is going to be 0, because if you substitute infinity, you're approaching 0. So any term that consists of e to the exponent minus st is going to approach infinity. It's going to approach 0. So to answer this, you're going to have 0 minus into, if you substitute 0 now into this whole thing, you're going to have 0 minus 1 over s squared. If you multiply the negative inside, your final answer will be 1 over s. So this is your final answer. This is how you're supposed to solve this question 5 and get 3 marks. Well, there's a better way which you can actually use. Let's say you're given f of t, which is equals to t. Well, if you check into your Laplace transform table, there's a rule that says n factorial all over s to the exponent n plus 1. And we can see that our n here is what? Is 1. So we can get the Laplace inverse by saying f of s is equals to 1 factorial all over s to the exponent 1 plus 1, which is equals to 1 over s squared. And you can see we have 1 over s squared. Even here we're having 1 over s squared. But fortunately here they require you to use what? To use the definition. So this is how you can actually confirm your answer using the table. This is how you're supposed to confirm your answer using the table.